Nagbabalik po ang DepEd Hour para sa Tele-Turuan. Itatampok po natin ngayong gabi ang ilang instructional videos sa mathematics at edukasyon sa pagpapakatao bilang pang-alalay sa alternative learning delivery ng sangay sa ating mga mag-aaral. Panuorin po natin ang magkakasunod na video lessons mula sa nabanggit na mga asignatura.
Good day! This is Sir Villamor R. De Leon, Teacher 1 from the Lampang Elementary School, your teacher presenter for today's episode of DepEd Tele-Turuan, Grade 4 Mathematics. Our lesson for today is all about changing fraction to lowest term. But before that, let's have a short review about greatest common factor. Find the greatest common factor or GCF of the following numbers. Are you ready? Let's begin. Number 1, 12 and 18. Very good. The GCF of 12 and 18 is 6. Number 2, 16 and 24. You are right. The GCF of 16 and 24 is 8. Number 3, 18 and 27. Very good. The GCF of 18 and 27 is 9. Number 4, 15 and 20. Very good. The GCF of 15 and 20 is 5. Number 5, 14 and 35. Correct! The GCF of 14 and 35 is 7. It is important that you know how to find the greatest common factor of numbers because we will use this in changing fraction to lowest term. GCF or greatest common factor is defined as the highest number that divides exactly into two or more numbers. To find out how to change fraction to lowest term, let's have this word problem. Nelson is helping Richard in cleaning the garden and watering the plants. They spend 2 hours doing this every Sunday morning. What part of the day do they spend cleaning the garden and watering the plants? Express your answer in lowest term. Who helps Nelson in cleaning the garden and watering the plants? Very good. It is Richard. How many hours do they spend in cleaning the garden and watering the plants? You are right. They spend 2 hours doing this every Sunday morning. What does the problem ask you to find? Correct. What part of the day do they spend cleaning the garden and watering the plants? Think. 2 hours out of 24 hours? In fraction, it is written as 2 over 24. And 2 over 24 is not in its lowest term. To change 2 over 24 to its lowest term, we have to do the following. Step 1. Find the GCF of 2 and 24 by listing all their factors. And the factors of 2 are 1 and 2. The factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. And their GCF is very good. 2. You are right. Step 2. Divide the numerator and the denominator by their GCF. 2 divided by 2 is 1. 24 divided by 2 is 12. So, the lowest term of 2 over 24 is 1 over 12. That means Nelson and Richard spend 1 over 12 of the day in cleaning the garden and watering the plants. A fraction is in its lowest term if the numerator and the denominator have no other common factor except for 1. Example. Change 2 and 6 times to its lowest term. Step 1. Find the GCF of 6 and 9 by listing all their factors. The factors of 6 are 1, 2, 3, and 6. The factors of 9 are 1, 2, 3, and 9. And their GCF is 3. Correct. Step 2. Divide the numerator and the denominator by their GCF. 6 divided by 3 is 2. 9 divided by 3 is 3. So, the lowest term of 2 and 6 ninths is 2 and 2/3. Let's have another example. Change 12 eighths to its lowest term. Step 1. Find the GCF of 12 and 8 by listing all their factors. You are right. Factors of 12 are 1, 2, 3, 4, 6, and 12. And the factors of 8 are 1, 2, 4, and 8. And their GCF is 4. Very good. Step 2. Divide the numerator and the denominator by their GCF. 12 divided by 4 is 3. 8 divided by 4 is 2. So, the lowest term of 12 eighths is 3 over 2. Let's have another one. Change 6 over 24 to its lowest term. Step 1. Find the GCF of 6 and 24. The factors of 6 are 1, 2, 3, and 6. The factors of 24 are 1, 2, 4, 6, 8, 12, and 24. And their GCF is 6. Very good. Step 2. Divide the numerator and the denominator by their GCF. 6 divided by 6 is 1. 24 divided by 6 is 4. So, the lowest term of 6 over 24 is 1/4. Again, when do we say that the fraction is in its lowest term? You are right. A fraction is in its lowest term if the numerator and the denominator have no other common factor except for 1. How to change fraction to lowest term? Very good. First, find the greatest common factor or GCF of the fraction. Second, divide the numerator and the denominator by their GCF. Now, it's your turn. Read and answer the following. Number 1. Reduce 4/8 of a pie to its lowest term. Number 2. Give the simplest form of 8 over 24 of cassava cake. Number 3. What is the lowest term of 3 over 12 of bibingka? Time's up. Let's check your work. The answer in number 1 is 1/2 of a pie. The answer in number 2 is 1/3 of cassava cake. The answer in number 3 is 1/4 of bibingka. There you have it. Please stay tuned for more discussion on our lesson about fraction. We'll be right back. Good day! This is Sir Villamor R. De Leon, Teacher 1 from the Lampang Elementary School, your teacher presenter for today's episode of DepEd Tele-Turuan, Grade 4 Mathematics. Our lesson for today is all about changing improper fraction to mixed number and vice versa. But before that, let's have a short review about types of fraction. Identify the following fraction, whether proper fraction, improper fraction, or mixed number. Are you ready? Let's begin. Number 1, 17 ninths. Very good. 17 ninths is an improper fraction. Number 2, 20 thirds. You are right. 20 thirds is an improper fraction. Number 3, 4 tenths. Correct. 4 tenths is a proper fraction. Number 4, 10 and 1/3. Very good. 10 and 1/3 is a mixed number. Number 5, 7 and 2/5. Correct. 7 and 2/5 is a mixed number. Fractions are numbers that represent a part of the whole. When the numerator is greater than the denominator, it is an improper fraction, while mixed number is a combination of whole number and the proper fraction. Do you know that we can change improper fraction to mixed number and mixed number to an improper fraction? Yes, you heard it right. To find out how to do it, let's have this word problem. Mr. Soriano and Mr. Santos are retailers of pizza. After a day, Mr. Soriano had 9/8 of pizza left, while Mr. Santos had 1 whole and 1 slice. Which of them had more? Mr. Soriano's pizza is cut into 8s or 8 equal parts. There were 9 slices of pizza left. We write this as 9/8 and read as 9/8. Mr. Santos Pizza had a whole and one slice left. We write this as 1 and 1/8 and read as 1 and 1/8. To find out which of them had more pizza, we have to change 9/8 to mixed number. To change an improper fraction to a mixed number, divide the numerator and express the remainder, if any, as a fraction. 9/8 is the same as 9 divided by 8. 9 divided by 8 is 1. 1 times 8 is 8. 9 minus 8 is 1. The quotient is the whole number, which is 1. The remainder is the numerator, which is 1. And the divisor is the denominator, which is 8. So, 9/8 is equal to 1 and 1/8. You are right. That means Mr. Soriano and Mr. Santos had the same amount of pizza left. Let's have another example. Change 15/4 to mixed number. 15/4 is the same as 15 divided by 4. 15 divided by 4 is 3. 3 times 4 is 12. 15 minus 12 is 3. Again, the quotient is the whole number, which is 3. The remainder is the numerator, which is 3. And the divisor is the denominator, which is 4. So, 15/4 is equal to 3 and 3/4. Let's have another one. Change 9/5 to mixed number. 9/5 is the same as 9 divided by 5. 9 divided by 5 is 1. Very good. 1 times 5 is 5. 9 minus 5 is 4. The quotient is the whole number, which is 1. The remainder is the numerator, which is 4. And the divisor is the denominator, which is 5. Very good. So 9/5 is equal to 1 and 4/5. Let's now talk about changing mixed number to an improper fraction. In changing mixed number to improper fraction, let's have an example. Let's have 1 and 1/8. Multiply the whole number by the denominator of the fraction. 1 times 8 is 8. Then add the product to the numerator. 8 plus 1 is 9. Write the result over the denominator. So, 1 and 1/8 is equal to 9 over 8. Let's have another example. 3 and 2/5. Multiply the whole number by the denominator of the fraction. 3 times 5 is 15. Then add the product to the numerator. 15 plus 2 is 17. Write the result over the denominator. 3 and 2/5 is equal to 17 over 5. Another one. 4 and 3/7. Multiply the whole number by the denominator of the fraction. 4 times 7 is 28. Then add the product to the numerator. 28 plus 3 is? Very good, 31. Write the result over the denominator. 4 and 3/7 is equal to 31 over 7. You are doing great. Again, how to change an improper fraction to mixed number? Very good. To change an improper fraction to a mixed number, divide the numerator by the denominator and express the remainder, if any, as a fraction. How to change mixed number to an improper fraction? You are right. Multiply the whole number by the denominator, add the product to the numerator, and write the result over the denominator. I think you are ready. It's your turn. Read and answer the following questions below. Number 1. Change 2 and 7/10 meters of cloth to improper fraction. Number 2. What is 12 over 7 slices of cake in mixed number? And number 3. What is 4 and 1/4 kilograms of tilapia in improper fraction? Time's up! The answer in number 1 is 27 over 10 meters of cloth. The answer in number 2 is 1 and 5/7 slices of cake. And the answer in number 3 is 17/4 kilograms of tilapia. That ends our lesson for today. Again, I am Sir Villamor R. De Leon, your teacher presenter for today. Good day! This is Sir Villamor R. De Leon, Teacher 1 from the Lampang Elementary School, your teacher presenter for today's episode of DepEd Tele-Turuan, Grade 4 Mathematics. Our lesson for today is all about subtraction of fraction from whole number. But before that, let's have a short review about subtraction of whole number. Subtract as fast as you can. Are you ready? Let's begin. Number 1, 17 minus 12. Very good. The answer is 5. Number 2, 26 minus 15. Correct. The answer is 11. Number 3, 21 minus 7. Very good. The answer is 14. Number 4, 32 minus 23. You are right. The answer is 9. Number 5, 35 minus 19. Correct. The answer is 16. Now, let's talk about subtraction of fraction from whole number. Let's have this word problem. Mr. Soriano baked 3 apple pies. Her children ate 5/6 of the apple pie. How much of the pie was left? Let's see this illustration. 3 minus 5/6 is equal to 2 and 1/6. Let's do the subtraction. In subtracting fraction to whole number, remember these 4 steps. Step 1, borrow 1 from the whole number. 3 minus 1 is 2. Very good. Step 2, convert 1 into an equivalent fraction with same denominator to the given fraction. 1 is equal to 6 over 6. Step 3, subtract the given fraction from the equivalent fraction you converted. 6 over 6 minus 5 over 6 is 1 over 6. Step 4, add the result from step 1 and step 3. 2 plus 1/6 is 2 and 1/6. Let's have another example. Father bought 2 kilograms of fruits from the market. He gave 5/8 kilograms to his helper. How many kilograms of fruits were left for his family? Let's do the subtraction. 2 minus 5/8. Step 1, borrow 1 from the whole number portion. 2 minus 1 is 1. You are right. Step 2, convert 1 into an equivalent fraction with same denominator to the given fraction. 1 is equal to 8 over 8. Very good. Step 3, subtract the given fraction from the equivalent fraction you converted. 8 over 8 minus 5 over 8 is correct. 3 over 8. Step 4, add the result from step 1 and step 3. 1 plus 3/8 is equal to 1 and 3/8. Let's have another one. Randy bought 1 whole cartolina. He shared 3/8 of it with friends. What part of cartolina was left for him? Let's do the subtraction. 1 minus 5/8. Step 1, borrow 1 from the whole number portion. 1 minus 1 is 0. Very good. Step 2, convert 1 into an equivalent fraction with same denominator to the given fraction. 1 is equal to 8 over 8. Step 3, subtract the given fraction from the equivalent fraction you converted. 8 over 8 minus 5/8 is 3 over 8. Very good. Step 4, add the result from step 1 and step 3. 0 plus 3/8 is 3/8. Very good. Again, how to subtract fraction from whole number? Step 1, borrow 1 from the whole number portion. Step 2, convert 1 into an equivalent fraction with same denominator to the given fraction. Step 3, subtract the given fraction from the equivalent fraction you converted. Step 4, add the result of step 1 and step 3. Now, it's your turn. Read and solve the following problems. Number 1. Mother divided a cassava cake into 16 equal parts. Her children ate 7 over 16. How much cake was left? Number 2. From 10 meters of wire, 3/4 was cut. How many meters of wire were left? Number 3. If 5 over 12 is subtracted from 5, what is the difference? The answer in number 1 is 7 over 16 of Cassava Cave. The answer in number 2 is 9 and 1/4 meters of wire. The answer in number 3 is 4 and 7/12. That ends our lesson for today. Again, I am Sir Villamor R. De Leon, your teacher presenter for today.
Hello everyone! Welcome to another episode of DepEd Hour Tele-Turuan. This is Sarina Saira B. Benabese from Imelda Integrated School, your teacher presenter for today's lesson in Mathematics 7. Our lesson for this episode is in line with Grade 7 Mathematics Module 5 for the second quarter, written by Ma'am Winelisa B. Felipe from San Jose National High School, and yours truly, Sarina Saira B. Benabese from Imelda Integrated School, entitled Laws of Exponents and Multiplication and Division of Polynomials. And these are the following objectives. Number 1, derives the laws of exponents. Number 2, multiplies and divides polynomials. Let us study first the laws of exponents. Are you ready? Before we proceed to our discussion, let us recall first what an exponential expression is. An exponential expression is an expression written in the form a raised to n, where a is the base and n is the exponent. The base is a number or variable that is being multiplied repeatedly in the expanded form. The exponent is a value that specifies how many times the base will be multiplied by itself. To derive the first law of exponents, let us complete the given table. For number 1, how can we write 2 cubed without exponent? That is correct. It is 2 times 2 times 2. And the product? Very good. It is equal to 8. How about for number 2? What will be our answer for the second column? Very good. It is 4 times 4. And for the third column? That is correct. It is 16. How about for number 3 and 4? Can you complete the table? That is correct. For number 3, we have to multiply negative 1 8 times by itself for the second column and 1 for the third column. For number 4, we have negative of 5 times 5 times 5 for the second column, and it is equal to negative 125. Can you find an easy way of finding the result written in the third column? What is it? The first law of exponents states that in a raised to n, a is called the base and n is called the exponent. The exponent tells how many times the base is used as a factor. Now, let us study the given table. Can you find an easy way of finding the result written in the second column? If you have not seen the rule, look and observe how the exponent in the second column is obtained from the exponent of the first column. Can you determine the second law of exponent? The second law of exponents is called power of powers, which states that for any number a and all integers m and n, the quantity a raised to m quantity raised to n is equal to a raised to m times n. Let us now proceed to the third law of exponent, which is power of a product. Again, let us study the given table. Can you find an easy way of getting the result written in the third column? What is it? Good job! Power of a product states that for any number a and b and any positive integer m, the quantity a times b quantity raised to m is equal to a raised to m times b raised to m. One of the law of exponents is product of a power. Let us study the first example in the given table. Observe the relation between the exponents in column 1 and 3. What will be the answer in number 2? For the second and the third column. That is correct. For the second column, we have A times B times B times A times A times A times B times B. And it is A raised to the fourth power and B raised to the fourth power. Can you determine the easy way of finding the result in the third column? Good job! For any number A and any positive integers m and n, A raised to m times A raised to n is equal to A raised to m plus n. And this is the fourth law of exponents, product of a power. Another law of exponent is quotient of a power. To understand this, let us observe the given table. Observe the exponent in column 1 and column 3. Can you find an easy way of finding the result written in the third column? What is it? You got it right. For any non-zero number A and all integers m and n with m greater than n, A raised to m over A raised to n is equal to A raised to m minus n. I think you understand the fifth law of exponents. Again, let us study and observe the table to derive the sixth law of exponent. Observe the given example in the table. Study the exponent in column 1 and column 3. How are they related? You're right. For any numbers A and B, where B is not equal to 0, and any integer m, the quantity A over B quantity raised to m is equal to A raised to m all over B raised to m. This concludes the sixth law of exponent. Another law of exponents is the law of zero exponent. To understand this, let us study the following example. Can you find the easy way of finding the result written in the third column? That is correct. Simply subtract their exponent, then remember the rule, any non-zero number or any variable, when you raise it by 0, is equal to 1. That concludes the law of zero exponent. For any non-zero number A raised to 0 is equal to 1. The eighth law of exponents is the law of negative exponents. Look at the table and observe how the exponent in the third column is obtained from the exponent of the first column. Can you derive the eighth law of exponents? What is it? You got it right. The law of negative exponents states that for any non-zero number A and any integer n, A raised to negative n is equal to 1 over A raised to n. And this ends our discussion about the laws of exponent. Please stay tuned for more discussion of our lesson in multiplication and division of polynomials. We will be right back. Welcome back in Tele-Turuan. Are you ready to learn about multiplication and division of polynomials? Multiplying and dividing polynomials is different from adding and subtracting polynomials because we consider not only the numerical coefficient but also the literal coefficients. Let us now study the multiplication of polynomials. There are several ways in multiplying polynomials. Letter A, to multiply a monomial by another monomial, simply multiply the numerical coefficient, then multiply the literal coefficients by applying the basic law of exponent. Let us multiply the following examples. Number 1. x cubed times x to the 5th power. That is correct. X raised to the 8th power. Since a raised to m times a raised to n is equal to a raised to m plus n, or simply the product of a power, that is x cubed plus x to the 5th power is equal to x raised to 3 plus 5, which is equal to x raised to 8. How about for number 2? Very good. 5x squared times negative 2x cubed is equal to negative 10x to the 5th power. Since 5 times negative 2 is equal to negative 10, and x squared times x cubed is equal to x to the 5th power. Another technique is to multiply a monomial by a polynomial. Simply apply the distributive property and follow the rule in multiplying monomial by a monomial. Let us study and observe the following examples. How do we get the product? That is correct. For number 1, we multiply 2 to each term of the polynomial x squared minus 3x plus 4. That will yield to 2x squared minus 6x plus 8. Same as with number 2, we multiply 4x squared to each term of the polynomial negative 2x cubed minus 3x plus 4. That will give negative 8x to the 5th power minus 12x cubed plus 16x squared. One more way is to multiply a binomial by another binomial. We use the distributive property twice. For example, we have the quantity 2a plus b quantity times the quantity x minus y. What will we do? That's right. We are going to distribute the first term of the first binomial to each term of the second binomial. That is 2a times the quantity x minus y quantity plus b times the quantity x minus y quantity. Simplifying the expression, it will yield to 2ax minus 2ay plus bx minus by. A simple memory aid is called FOIL method. FOIL stands for F, first, O, outer, I, inner, and L, last. Let us try this. Multiply the quantity 3x minus 2y quantity times the quantity 2x minus y. What will we do? That is correct. First, multiply the first terms. That is 3x times 2x, which is 6x squared. Next, multiply the outer terms. That is 3x minus. Next, multiply the outer terms. That is 3x times negative y. It will give negative 3x y. Then, multiply inner terms. It is negative y times 2x. It will yield to negative 4xy. Finally, multiply the last terms. It is negative 2y times negative y, or which is equal to 2y squared. The result is 6x squared minus 3xy minus 4xy plus 2y squared. Combining similar terms, the answer is 6x squared minus 7xy plus 2y squared. Finally, the distributive property can also be used to multiply polynomials of any number of terms. To show how to use it, let us study this example. Multiply the quantity x minus 5 by the quantity x squared minus 2x plus 1. First, multiply the first term of the first factor to each term of another factor, and then multiply the second term of the first factor to each term of the other factor. Simplify it, it becomes x cubed minus 2x squared plus x minus 5x squared plus 10x minus 5. Combining similar terms, the result is x cubed minus 7x squared plus 11x minus 5. Another way to do it is by vertical method. And here is an example. And that ends our discussion about multiplication of polynomials. Another topic that we are going to discuss is about division of polynomials. Like in multiplication, there are several techniques in dividing polynomials. Letter A, to divide monomial by a monomial, divide the numerical coefficients and then express the quotient as a rational number in simplest form. Then apply the laws of exponents and make all exponents positive. Let us have an example for this. We have 24m squared n to the 4th power all over 8m cubed n squared. It is equal to 3n squared all over m. How? That is right. Since 24 divided by 8 is 3 and a raised to m divided by a raised to n is equal to a raised to m minus n. Then, m squared divided by m cubed is equal to m raised to negative 1 or 1 over n. And n raised to the 4th power divided by n squared is equal to n squared. How about for negative 20 x cubed y to the 5th power divided by 4x squared y squared? What is the answer? Very good. It is negative 5xy cubed. Another way is to divide polynomial by a monomial. Simply divide each term of the polynomial by the given divisor. For example, 16x to the 5th power minus 20x to the 4th power plus 4x cubed divided by negative 4x squared. We simply divide each term of the dividend 16x to the 5th power minus 20x to the 4th power plus 4x cubed by our divisor 4x squared. And the result is negative 4x cubed plus 5x squared minus x. Or you may use the vertical way of division like this. Another technique is to divide polynomial by a polynomial with more than one term. We're going to use long division. Simply follow the procedure in dividing numbers by long division. There are several steps. These are the steps to follow in dividing polynomial by a polynomial with more than one term. Number 1, check the dividend and the divisor. If it is in the standard form, arrange the terms in descending order of powers. Insert 0 for the missing terms of the dividend or the divisor. Number 2, set up the long division by writing the division symbol where the divisor is outside the division symbol and the dividend inside it. Number 3, you may start the division, multiplication, subtraction, and bring down cycle. Number 4, you can stop the cycle when letter A, the quotient or answer has reached the constant term. Letter B, the exponent of the divisor is greater than the exponent of the dividend. Divide 208 by 3. Set up the long division by writing the division symbol where the divisor is outside and dividend inside it. Divide 20 by 3. The answer is 6. 6 times 3 is 18. Then, subtract 20 by 18. The result is 2. Bring down 8. 28 divided by 3 is 9. 9 times 3 is 27. Then, 28 minus 27 is 1. 1 is less than the divisor, so we are going to stop. In the given example, the dividend is 208, the divisor is 3, the quotient is 69, and the remainder is 1. Our final answer is 69 and 1/3. Generally, you can write dividend divided by divisor is equal to quotient plus remainder over divisor. Now, let us have an example in polynomial. Divide 3x cubed minus 4x squared minus 10x minus 5 by 3x plus 1. First, check the dividend and the divisor if it is in standard form. Then, set up the long division by writing the division symbol where the divisor is outside the division symbol and the dividend inside it. Divide the first term of the dividend by the first term of the divisor. We have 3x cubed divided by 3x, and it is equal to x squared. Multiply x squared by 3x plus 1. We have 3x cubed plus x squared. Subtract 3x cubed plus x squared from 3x cubed minus 2x squared. The answer is negative 3x squared. Bring down the next term. Then divide negative 3x squared by the first term of the divisor, and the answer is negative x. Then multiply negative x by 3x plus 1. We have negative 3x squared minus x. Subtract negative 3x minus x from negative 3x squared minus 10x. The answer is negative 9. Bring down negative 5. Negative 9 divided by 3x is equal to negative 3. Negative 3 times 3x plus 1 is negative 9x minus 3. Subtract negative 9x minus 3 from negative 9x minus 5. The answer is negative 2. Since negative 2 is less than the divisor, we have to stop. The final answer is x squared minus x minus 3 minus 2 all over 3x plus 1. There you have it. Again, I am Sarina Saira B. Benabese, your teacher presenter for today. Thank you for watching.